Hello, so this is our second special compound change video, and this time we're going to focus on looking at how to calculate the unknown time. So the last video we looked at going back to find the original amount after a repeated change. Today we are focusing on trying to find the number of years or months that you have left your money in the investment account or whatever it is. And then the final video that I will make will be about finding the actual multiplier or the percentage that it has been increased or decreased by. But we'll do that in the next one. That's the most difficult. This one is a little bit tricky, but it's actually a lot of trial and error, which makes it just a little bit more long-winded. But anyway, let's have a look at how we do it. So we have £1,000 in the bank account, 10% interest every year. How many years after how many years will the amount I have reach above £2,000? So we're looking to double our investment, but we want to know how long that's going to take us. So if I put it into the formula, I have my original £1,000. I've multiplied it by my percentage multiplier. Interest is always an increase, so 100% and 10% is 110%, which is 1.1 as a decimal. So that's my decimal multiplier, and it is the power that I don't know, the number of years that I don't know. So I'm going to call that n, and that is equal to 2,000, or I want it to be equal to 2,000. It might not give me 2,000 exactly because, we're saying how many years will it reach above 2,000. We probably are not going to get 2,000 exactly. And you'll see what I mean as we go through the rest of the questions. So we again need to rearrange to try and isolate n on its own. Now the issue with this is that it's trapped in the power, and we don't learn about how to work out that value that is a power until A-level. We could use logs if we were doing A-level. However, we don't know about logs yet. Not at IGCSE. It's not an IGCSE skill. So we have to use a little bit of trial and error to try and find what that n is. But I can rearrange to get it as isolated as I possibly can. So I'm going to divide that 1,000 over to the other side. So with 2,000 divided by 1,000 is 2. So I'm looking for a power of 1.1 that gets me as close to 2 or above 2 as possible. And again, there's no way of doing that other than just trying some values of n. So I'm going to start quite high because I can always make it smaller, but I'm going to start with 1.1 to the power of 4, which gives me, and again, I'm literally typing it in my calculator and seeing what I get. That gives me 1.4641. So it's still too small. It's quite a bit too small. It's like 0.6-ish, too small. So I'm going to go bigger again. I'm going to go 1.1 to the power of 6. That gives me 1.77, 1561. Again, still too small. I'm going to just go up 1 power, 1.1 to the power of 7. That gives me 1.9. I'm very close now, but still too small because I'm trying to get to 2 or bigger than 2. So let's try 1.1 to the power of 8. I think this is going to be the one. 1.1 to the power of 8 is 2.14. So yes, it's not 2 exactly, but it's bigger than 2. Okay, so again, the question says, how many years will the amount I have reach above £2,000? So this power of 8 will give me a number that is bigger than 2,000. I can check that by putting it back into the equation. So I've got 1,000 times 1.1 to the power of 8. That gives me 2,143.59 when I round it correctly, pounds. and that is above £2,000. If I'd done it with the power of 7, I would still be just under 2,000. I'd have 1,900 and something. That would be too small. So I need to be bigger than 2,000. So I use the power of 8. Okay. So it's just trial and error, trying different values of the power until we get as close to 2 as possible. And then just to make sure, just to double check that you've got the right answer, we pop it back into the equation. Just to make sure, just to double check. Our answer is 8 years, so it takes 8 years to be above £2,000. It takes 8 years, okay? So again, I've got another question. I'm going to read it out and then I'm going to pause. I'd like you to pause the video, try this yourself, and then come back and watch the solution to make sure you are doing it correctly. So we have Gwen. She's bought a new car. Each year, the value of the car depreciates, so it's decreasing by 9%. Calculate the number of years after which the value of her car was 47% of its value when new. So there's a few things going on there. It's decreasing this time, so be careful with your multiplier first of all. And it's not giving you an actual number. It hasn't told you how much she bought the car for. So my hint for that is pick a number. Okay, so choose a number. Choose one that's quite easy to work with. I would choose 100 or 1,000 or something like that. But choose a value for the car if it doesn't tell you one. Pick your own. Then work out how much it would be after when it's 47% of its original value, and then work out the number of years. So I'm going to pause now, have a go, see if you can do it. It is quite tricky, and then come back and see the solution. Okay, so I hope you paused that and worked out yourself. Here is how it should be done. So I'm going to choose 1,000. So I'm going to say she bought her car for £1,000. Because it's depreciating, it's decreasing by 9% each year. 100% minus 9% is 91%, which is 0.91 as a decimal. So that is my decimal multiplier. The number of years is what I'm trying to work out. And we're looking for it to be 47% of its original new value. 47% of 1,000 is 470. So we're looking for it to be £470. Okay. Again, we can't isolate the n completely, but we can remove some of the things surrounding it. So we're going to divide by that 1,000 to get 0.91 to the power of n is equal to 470 divided by 1,000. Which is 0.47. Isn't it? Yeah. 470 divided by 1,000 is 0.47. Okay. Maybe I've overcomplicated that. Never mind. So we need to keep multiplying 0.91 by power until we get 0.47. So what should I try first? I might start with 3, see what that gives me. 0.91 to the power of 3 is 0.7535, and then a few more decimal places. Okay, so I'm going to go a bit bigger. I'm going to go 0.91 to the power of 5 and see what I get then. That gives me 0.62. I think this is going to be quite a high number of years. 0.91 to the power of 7. We can try next. That gives me 0.51676. Getting a lot closer. Let's try 0.91 to the power of 8. Surely it's not going to be 8 again. It is. That gives me 0.4702, etc. But if we round that, that's 0.47, that's 47% of the original value. So again, we could check that. You could put that 8 back into this equation and pop it in there and just double check it if you wanted to make sure you're getting it correctly. But the answer is 8 years. It takes 8 years for the car to be 47% of its original value when new. I hope that makes sense. I hope you got that question right. Yeah, thanks for watching, thanks for listening, and have a lovely day.